Okay, this is week 10 and PCT110. This week class is going to be online due to a schedule conflict. If you go ahead and watch a podcast and do a take home this week, the podcast needs to be watched by this Thursday, 10/27, and by 10 p.m. would be great. There'll be some questions that you need to answer as you're watching a podcast. At the end of the podcast, you'll submit the answers to the podcast exercise Dropbox right here. There's also a subnet exercise take home due next Thursday. And it is here, the week 10 lab. It's a Word document. Read the instructions inside of the week 10 and follow the instructions, complete them, and turn in a hard copy of that, or submit it in the Dropbox, by next Thursday. So you'll download and edit this above Word document, read and look at the examples. A couple is a network ID, IP binary conversion. Submit this below by next Thursday. Give you a while to finish that one up. Also, a reminder, the network call assignment we talked about and assigned last week. Continue to work on that. That assignment is due Sunday, 11/6. So again, watch podcast by this Thursday, answer some questions, submit the answers in the week 10 podcast exercise, complete the week 10 lab, which is a subnet exercise that's due next Thursday, and then the network call assignment, work on that one. You have a couple weeks still on that before it's due. And as always, review questions and quiz is due this week as well. So let's go ahead and get into the presentation. This week's chapter is talking about network operating system. And looking at the network operating systems in the next few slides here and what they're comprised of and why they exist and what their function is in a network. Some of the characteristics of a network operating system is it's based on a client-server architecture. The network operating system manages resource sharing. The NOS also provides many other functions, some built in, some configured at installation, some are default customizable settings. The NOS also components are varied by the different version of a network operating system that you're installing. So networks use servers that generally will exceed a minimal hardware. And you need to determine whatever the optimal server hardware might be for your location. Some of the questions you might ask is what kinds of applications will run on the server. Like for instance, Microsoft Exchange might run on the server. Might host a web server. It might be a authentication piece. How many clients will be connected? Because cost-wise, that will make a difference. How much storage space will each user need? It could be a default of say 20 megs. It could be 1 gig, just depending on your location and what the user's needs are. How much downtime, if any, is acceptable? You generally have a current infrastructure in place and you need to determine the downtime for upgrading to a new network operating system and server. And then what can your organization afford? The first, determining optimal server hardware. First is what type of applications. Like I said, Exchange is one, web servers another, a host of other different applications that could be running. Maybe Microsoft Office you're pushing out to end users. The vendor that you choose to buy your server hardware from. Example, Dell, Gateway. Do they have high quality, dependability, technical support? You can talk to other network admins within your area or in your line of work to determine reputation in your area. Reliable server. You need to spend as much as necessary. Example, component failure, widespread effects. What type of support do you have? Important NOS function. It allows efficient communication, it allows resource sharing, and that's an added benefit that clients do not have. Client peer-to-peer does not have. Now, network operating system client support, creating and managing client accounts, enabling clients to connect to the network, enabling clients to share resources, managing clients across a shared resource, and facilitating communication between clients. Server process also takes care of when users log in from whatever location. They take care of the login process, redirector, handling requests, determining where it should be handled, file access protocol, working with other client types, Macintosh, Linux possibly. Broad support allows every client type to authenticate. So here's an example of a file server and multiple clients out here. And a client redirector determines if this resource client can or cannot connect to the server. Middleware is the other piece. This translates requests, responses between client and server. And then three-tier architecture is a client-server environment that incorporates middleware. So here's an example of a Mac, Windows, and Linux. You've got middleware here in the middle and a server. Middleware can be anything from hardware, software based. Middleware could be a software possibly that talks to all three of these and pushes it to the server. So I'm going to stop there and ask the first question, which is describe three functions a server uses to communicate to clients. Describe three functions a server uses to communicate to clients. And you can pause the podcast if you want to go back in the podcast to find the answer, write it down in Notepad or Word document, and continue on. Okay, next we're talking about users and groups within networks operating system. One is client authentication. The client gains access to a network operating system service and resource. The first type of user account is going to be administrator account. It's the most privileged user account, the one used to set up the server, has unlimited rights to the server, domain resources, objects. This is created by default. In the Linux, Unix world, it's called root user. Usernames. The network operating system grants each user network access to files and shared resources. And then one added benefit to network operating systems is being able to create groups, bases for resource and account management. This assists in resource sharing, security control. Example, a network administrator for a public elementary school would have different shared resources than a student or a teacher would have. So here we have group teacher has read rights to modify the programs, rights to grades, full control, rights to staff, no access. Student, read to programs, no access to grade, no access to staff. Administrators, no access to rights to programs, but can read and modify rights to grades and full control of rights to staff. So the users and groups are nested in a hierarchical group arrangement. This simplifies for management, like in the prior slide, students, faculty or staff, and administrators, 3 groups. You can have a group arrangement that when users are added to that group, it affects their permissions, and those permissions are inherited from the parent group. After a user or group restrictions are applied, the client then can be allowed to share network resources. So some of the identifications of organizing elements within a network is, in the modern network operating systems, is to have similar patterns for organizing information, such as most all NOSes will have users, printers, servers, data files, applications. It'll also have directory structure of some type that will talk to each other, which is called a file system directory. The next protocol that's pretty cross-platform today in NOSes is LDAP. It's called stands for Lightweight Directory Access Protocol. It's used to access information stored in a directory. It is an object of a thing or a person, generally a user. The attributes are associated with that object, and schema set of definitions such as location, username, password. Schema generally in this type is going to be, again, location of where it's located on the tree, which we'll talk about in a second, for that network. So we have a NOS directory, user account, computer, printer, domain, the schema, the name of the object, identifier, required and optional attributes, syntax, parent relationship, falling right into the username, full name, password, home directory, the description, and can they maybe remote access, as an example. LDAP has to use generally containers or OUs for organizational units. They're logically looked at and subdivided within a network receptacle. They have some type of account, like a user record containing all properties. And the standard for LDAP is generally directories and contents that form trees, which we'll look at in a second. And a tree basically is just a logical representation of a multiple levels within a directory. Example, the root, branch, and leaf algorithm. The root of a tree is the furthest down you can get, and then the branches, you can add leaves to branches, you can add other branches to branches, and then finally leaves, which is the last part of a tree, which you can't add anything. A leaf cannot add anything to it. So we'll look at that algorithm in a second. So here we have the root of a tree. We'll say it's ABC company. This level here is branches. Branches containers could make up of groups within an organization, marketing, HR, sales, programmers. You'll notice also these branches can have sub-branches as well, just like in a regular tree. And then finally, leaf objects would be considered as users, printers, file servers, switches, all would be leaves. You can't add to those. But containers you could. So before you install a network operating system, you plan your tree of some, as we mentioned in the prior slide, consider future needs. For example, a new manufacturing firm, maybe called Circuits Now, currently has printers, users, and computers. This is the OU Circuits Now, printers, users, computers, but now they're expanding, and maybe they have a future chips section and transistor section that they're going to be adding. Okay, next question to answer is, what benefits are there in creating groups for users? And give an example. The one I gave in a slide was, I believe, administrators, faculty, and students. But you can give your own example. You can pause the podcast, answer, come back. Okay, next is shared applications. After you purchase a server, you've installed the, you realize how many clients you're going to, users are going to be connected. You've drawn your tree. Next, you're talking about shared applications. How many shared applications are you going to have on that file server? Specifically designed to run applications, because most of these applications have either a per user or per seat license or a site license. So per user would be just that. If you buy a 10 user license, only those 10 people can use. A per seat, if you do like 10 seats, 10 concurrent users can be logged on at the same time to an application. So you'd have 30 employees, but only 10 at a time could use it. And then site license would be unlimited use on your business site for that application. When you're installing an application on a server, you have to purchase an appropriate type and number of licenses, verify it is a server resource, and you have enough location space on the server, memory on the server. You install the application, make it available to users, and then provide users access and generally training to that application. The NOS is responsible for arbitrating file access, and problem with shared file access is multiple users can simultaneously access the same data and the same program files, which could cause conflicts on reading and writing possibly, and that is an issue to deal with. Shared printers. This is another resources that NOSes can give to a network client architecture. By sharing printers, you can reduce cost, manage printers from a central location, and all NOSes perform common tasks in managing printers, from Linux to Macintosh to Windows. An example here of multiple workstations sharing printers throughout the organization. To create a new printer, you install the driver. Generally, it's going to be installed on the network itself, network server itself. You ensure that the appropriate printer queue has user rights. Then the network printers will appear as icons in printer folders, and a client redirector is then determines where that print request should be transmitted. Limited server system resources within a server is required by multiple users. You wouldn't want unlimited resource to your users because hard drive space can be eaten up pretty quickly. So you want some type of cap that you can cap upon the creation of a user within Active Directory on the amount of file space that they have. All modern NOSes have this capability to maximize server memory, processor, bus, and hard drive space. This accommodates the client requests faster, improves overall performance. Next is virtual memory. This can boost total memory available. I generally recommend leaving virtual memory alone and letting Windows Server handle that memory, the virtual memory the best, and then installing as much RAM as possible that server can allow you to install. Virtual memory is stored on a hard drive and does take up processing or resources, which can slow down server processes. That's why I recommend beefing up the RAM and leaving the virtual memory alone, allowing Windows to manage that memory. Virtual memory advantages, easily expands memory available to server, but then the downside to this is slow operations because it does utilize hard drives space versus physical memory. Multitasking, execution of multiple tasks one at a time. All operating systems perform on this schism from Windows client to server. Server differences, the fact that they can happen quicker on a server because of multiple processes. Processing can be applied. You can have multiple integrated systems within one server. Increased response time, increased instruction time, processing time can be increased as well or decreased because of server with high processing uses. And one of the main benefits of server is the fact that you can have multiple processes, multiple processors within one server. Here at the college, we have multiple servers in the IT server room that have 8 or more processors within each server. Those processors are daisy chained together to where you not only have the processing speed of the processor chained together, but all the memory also chained together to look as one within the server resource. So go ahead and go to the next question. Define two resources that servers can share with clients, and what benefits are there in servers handling multiple processors, which I've just talked about at the college and also on the prior slides. So again, define two resources servers can share with clients. What benefits are there in servers handling multiple processors? You can pause the podcast, answer those questions, and come back as always. So Windows Server 2008 was released in February of 2008. It was an enhancement of 2003. Still has a GUI interface, enhanced security, reliability, remote control support, new server management tools, multiple editions, standard web enterprise data center, popular network operating system. It addressed most network admins' needs very well. Well-established vendor Microsoft, program compatibility and device compatibility, very large market share, and technical support. Benefits, several general benefits, simple user interface. Disadvantage, past criticism, performance, and security. Hardware requirements on Server 2008, high processing power, memory was increased, more memory was increased to be allowed, more hard drive space was increased as well. The server compatibility computer components available online, and you need to consult it prior to hardware purchase. Here's the minimal requirements in this table here. I won't read through it. These again are all minimal requirements. For instance, notice the minimal requirement of 512 megabyte of RAM is the absolute minimum. You would never get that for a server though. There is two types of server schemes. One is a 32-bit, next is a 64-bit. There is a lot of servers going towards a 64-bit as well as clients as well. Faster processing. It logically divides memory in a more efficient manner. And Windows Server 2008 has both 32 and 64-bit. This just shows an advanced tab within Windows 60 or Windows 32-bit that allows you to choose how to allocate processor resources. In this one, it's adjusting for background services over programs. Next is a file service, or the file system for servers, network operating systems. File system just manages and organizes files within a server. NTFS is the new technology file system installed by default within Windows servers, starting with Windows Server 2003. Disk data distribution. This divided and allows you to subdivide your network drives easily within a NOS. Advantages of NTFS: is very secure, reliable, has built-in file compression, handles massive files over 2 gigs. One of the limitations of FAT32 was 2 gig file limit size. Allows file access faster, used on all modern Windows operating systems since Windows NT, and many features are built in. Drawback: it cannot be read by older operating systems, cannot be read by older operating systems. Back to Windows 98 can read NTFS but cannot write. Windows 95 cannot read NTFS or write. Active Directory. This is a directory service built into Windows, designed in 2000, enhanced with the current version of Windows Server 2008 and now 2010. Has a workgroup model and a domain model. This allows you to manage groups and users within your network, pushing rights and resources to the clients on a need basis. Workgroups within this environment of Active Directory is a peer-to-peer network. You have a decentralized management area from within Active Directory where each computer has its own database, users and security privileges. It's practical for small networks, for your users, and simple design. Now, Workgroups, different than Active Directory, is generally used for smaller networks that are not going to have many users on them. I'd say under 10. Anything over 10, I would recommend utilizing Active Directory over Workgroups. Domains. This is a group of users, servers, and other resources. This is utilized by Active Directory in a client-server architecture. It has a database, a domain database. It's very easy to organize and manage resources centrally, from users to groups to printers to other file servers, all within the Active Directory environment. And lastly, ending on this slide, showing you a tree of multiple areas by a domain within Active Directory in a domain tree. This will be a university domain, and then the different departments: life sciences, humanities, communication, engineering, and then engineering having 4 branches underneath that. So let's go to the final question. Which is, what file system does a Windows server use, and what is OU created for on network tree? If you need to go to prior slides, that would be fine. Answer the questions and submit these as one file in the Dropbox for this week. Let me go ahead and go there real quick. So once you're finished with the questions, you go into the Lessons tab, Week 10, and it's Week 10 podcast exercise, where it says watch and answer questions at the end of podcast. You can paste those answers right into the message of the body here, or put in a Word document. Title first and last name as always, and submit, and have this done by Thursday. And then just a recap on what else is due coming up. Subnet exercise due next Thursday. That's found in the Week 10 lab. And you are to open up this document, follow the example and exercises, finish the exercise, submit below, name here, attach the document when you're finished, and that's due by next Thursday. Also, review questions and quiz, as always, is due by Sunday. And if you have any questions, give me an email. Otherwise, I'll see everybody next a week from this Thursday. I believe is going to be November 3rd.